Good morning, everyone. Talking about asset management and data, so I'm not going to bore you with too much detail on the data. I'm just going to share the process that can be used to model if you want to forecast the cost of an existing building, or if you need to extend the life of the building. Then look at the accurate modeling of, okay, what do we need to spend over the next 10, 15, 20 years to keep this hospital or this facility operational. So in the very first speech yesterday morning, I think Blake mentioned in Queensland Health, they are over 1 million square meters of facilities coming toward the end of the life. And if I remember correctly, he said they used to build 80 square meters a year or 100. So basically, the facilities are getting close to the end of the life in millions of square meters. We're building in hundreds of thousands. They are the case where hospital strategic plan will say, okay, this facility or this building 5 is end of life in 2032. We need to keep it running for up to 2040. So if you want to go back to finance or the one making decision, and we want to give them informed detail or accurate modeling that, okay, what's need to be done to extend the life of this building for extra 5 years or extra 10 years. So they're very important, and the prep for that is obviously preparing the data. So you're looking at, okay, we need to look at what asset we are maintaining. Then we need to look at, okay, what are the condition of the assets? What are the issues in the existing facility that we try to keep run for extra 8, 10 years? And then what are the cost components and so on? So it needs to be accurately defined. What are we modeling, and what are the cost components? So yeah, we look at the building and facility assets. So in this model, the biomedical asset were excluded, but basically the model, we just going through the process. Then we, when we talk about data, we collected the data of what are the assets in that hospital, in that particular building, and then, okay, for each asset, what do you need to maintain it, and what are the expected costs for the corrective works? If there is any issues, we need to, for example, address the non-compliance in this particular place or the asset. Then what needs to be done, and that would give us, with a bottom-up model, give us the cost over that life cycle that we want to look at the facility. So as I said, we only focus on the building and facility. The cost model uses the 5 cost model. So preventive maintenance, which is combination of statutory maintenance and also the maintenance that we have to do, the routine maintenance that we have to do to keep the reliability of the facility, to service the patient, and also the staff. Then based on each asset would have extended life. Also, we want to, okay, run this building up to 2040 or 2045, but that chiller is end of the life, has to be replaced in 5 years' time. So what needs to be replaced? Some of the complex assets, also they last for 20 years, but at some stage you need to spend some money and refurbish them, make them reliable and to the service level that they expected from the assets. The last component, which is very important and could be very costly as well, is addressing all the issues. An old building, we have lots of, we might have some non-compliance or inefficiencies that if the building is going to retire in 2030, we might just patch things, but if we want to extend the life for another 10 years, then, okay, we have to do more fundamental and define a project to address those issues. So we look at these 5 components for that defined set of assets. Obviously, I said we just sharing the process. Other than that, it could be applied to any facilities and so on. I'll share with you the result for a sample result, let's call it. There was like 5 hospital facilities, 5 buildings, not the whole hospital, and a couple of other non-hospital facilities. So I put the average there just to give you an idea of the type of the cost that we talk about. So the very first one is the very first step, which is very time-consuming and need a bit of engineering effort, is identifying, okay, if we're modeling this hospital and we're looking at the building and facility, what are we modeling? What are the assets that we are maintaining, basically, and then the condition of these assets. In the hospitals, the good asset management system, you have a 90% confidence, but then during the year, this is an old building, there are some assets that have been removed, they're still sitting in the asset management information system, or there are some new assets installed and they never registered, or the condition, for example, yeah, this asset was in excellent condition when it was installed back in 2015, no, it's in the final stage of its life. Or in, we found there are lots of cases where the client doesn't have asset condition registered in the database. So there is a bit of work that go through and identify the assets, make sure you're, because it's a bottom-up model, we have to make sure that the data we work is accurate. And then also we're doing the condition assessment of the assets, the current condition, to make or understand that, okay, this asset, we don't have condition, or either we need to have to know when it was installed, so the model can expect, okay, it's the end of the life is going to be 2035, or what is the installation date, or the current condition. And then you end up with, for example, in one building, we had just over 10,000 assets. So it is not going to be one by one. It's very difficult for life cycle cost modeling. So we have to, you have to use, for example, a classification, let's say VBIS classification, and based on the classification, you'll end up, okay, saying the cooling tower or a chiller is expected life is 10, 15, 20 years. So basically, we're going to replace this piece of asset in 10 years, 20 years. And then some of the assets you may need to refurbish, as I said. Like that cooling tower, you halfway through the life, you refurbish the cooling tower. It is also very important to consider the condition or environment. For example, a cooling tower in a office block might last 25 years, 20 years, but in the hospital, or if the hospital is 200 meters from the ocean, it's going to last only 15 years, so you're not going to get the full 25 years. So you review those cost components, so then at the end of this stage, just to give you an idea, for 5 major buildings, it took about 6 weeks for 3 to 4 engineers to go through and validate the assets and get the condition, the current condition of the assets accurately as possible. So after that, it's a bottom-up model runs on those assets that we identified. So we know the assets, we know the asset classification for each asset, then we got a preventive maintenance strategy in place. Let's say it's a chiller, you go every month, you spend 2 hours, and that 2 hours you need an electrician, then every 6 months you got a fitter, needs to go spend 4 hours, and then the rate, you come up with the rate that if it's a contractor and so on, then you go through basically run the model across all the assets, which is going to be by asset classification, as I mentioned, and give you an estimated, okay, this is the number of hours and the equivalent dollar figure for preventive maintenance across this building or across this facility. There are some elements that you have to add. For example, if we look at, for example, that monthly PM takes 3 hours, you need to consider you need an admin, you need a supervisor, and the overhead costs associated. So again, bottom-up model, go through all the assets. Some of the assets you don't need routine maintenance. Obviously, then you exclude those. It's based on the asset class. And you end up, okay, this is the first component. For the second component, the asset doesn't matter how much we maintain them, they're still going to fail. So you look at the corrective maintenance, where the pump that we had a 3 monthly and 6 monthly maintenance, at some stage in between, it might have a leak that we have to go and fix. So those corrective maintenance, again, looking at analyzing the history data for for similar facilities, we come up with, for example, a ratio of the corrective maintenance to preventive maintenance. If you look at the asset management information system across some facilities over the last 3-5 years, recently, for example, for a new building, it's about 44%. For a brand new, 10%, and then as the asset age, the failure rate goes up, and then you need to spend more time, and it goes. So with the life of the assets, if you put a new assets, or if you, for example, find the asset in the fair condition, then whatever the PM allocation for that chiller, then you consider 58%, or as its age, if it's in poor condition, this increases to 87 and 116. So again, the same thing, you go bottom up, you know the assets, you know the asset classification, and we know the PM estimates, so we come up with the budget figure for corrective work. Obviously, it's a statistical model. You're not gonna, every pump is not gonna fail, or every air handling unit, but yeah, you might spend, on one air handling unit, $10,000, the other one might be, doesn't fail the whole year. So that's the second component. The third one is straightforward. As I said, when we're modeling, if we want to report to the finance department, we agreed on the life cycle expectancy. And as I said, we either have the installation date, or even better, if we know the current condition. Based on that condition, we said, okay, if it's in the fair condition, it's got 50% of the life left. If the asset is, that asset class got expected to last for 20 years, so I need to put a budget aside in 10 years' time to replace that air handling units. And then you also have it's rarely that we have accurate costs in asset management information system. That's why we developed all this data by asset class. So we say, okay, in our library, that asset, the minimum library cost is $25,000 across the historical data that we have seen. The maximum is, let's say, $260,000, and on average, it takes $172,000 to replace this asset. Then in the modeling we said, okay, if the asset management information system or database they site have, if it's more than a minimum, we use the actual replacement value, but usually you don't have that replacement cost in your database, so we just go with the library average. So basically, asset by asset against a bottom-up model, we said, okay, we've got 20 air handling units, they are all due for replacement in 2035. Each of them costs $150,000. We need $3 million to replace the 20 air handling units in 10 years' time. So that gives us the life cycle replacement component. The next one is refurbishment. Again, similar methodology. I'm not going to spend too much time. Some of the assets, like fire extinguishers, you're not going to refurbish it after 5 years. You don't even do the 5-yearly test. You might replace the whole fire extinguisher. But yeah, for those major assets, you need to do a refurbishment once or twice during the life of the asset. And then some of the assets would have, even in the life cycle modeling, you would have multiple replacement during that period that we're modeling. And then, yeah, again, bottom-up model, it gives you the budget per year for this cost component. Then the very important one is the chronic issues that we have. And that one needs a bit of effort to identify. And when you do asset condition assessment, you walk through, you might across, okay, this handrail is not compliant. You might, okay, that there is an issue here, you record it. But in the hospitals, there are lots of other issues that you need to, we sat with facility managers and also went through a whole bunch of reports the last 5-7 years. They all reports that, okay, 5 years ago identified, okay, there is an issue in this building, it's critical or high priority, and then you ask, was it implemented? The answer is no, we haven't done anything, we didn't have budget. So you go through all the reports, you do your site visits, and you also sit with the asset management team. And also, there are other components that you have to consider. If we're extending the life by another 10-15 years, the hospital will have to be fit for purpose in recent environment or in 5-10 years' time. So some of the examples is like mold in the ductwork. If you walk through Plan rooms, you don't see it, but when we sit with the service provider that service the HVAC assets, they will tell us, okay, in this duct we got mold, and then we need to replace it or have a monitoring system in place for that issue. And the other issues that, again, like one of the interesting one was the hospital bought a whole bunch of new patient beds just to know that, just to realize after they arrive that they don't fit in the main hospital lift, so they have to modify them and to be able to fit that, or just modify a couple of lift to be accommodating those beds. Then I said the capability of the system is also very important. One of the issues that we needed to consider is, for example, the ICT infrastructure. Being an old building, they had a, Cat5, these blue cables that thousands of meters, they run across everywhere and transferring the data. The building as it is compliant because it was built back in 15 years ago, and that was to the standard back then. But if you do a major refurbishment, or if you're putting all these new high-tech facilities in the hospital in 5 years' time, then you need to, the current standard, I think, say 6 or 6A. So we have to put a budget aside that upgrade all these cables to categories Cat 6A. So that's another cost that you only realize when you sit and talk with the asset managers and the contractors that are servicing the facilities. So all these identified against 3 sources: site visit, talk to the asset management team, and talk to the service providers, and also go through all the reports accumulated for those buildings over years. Then you risk rank them based on priority, and the hospital would have a say, if it's priority 1, has to be addressed immediately. If it's high priority, then you add this in 1-2 years. So you schedule them based on the risk ranking and the priority assigned to that. And one important factor for defining the cost of this project, for example, we might go to Royal Instance and say, okay, 2 cooling tower replacement, $500,000 each, it's end up $1 million, and they claim that it's include the installation cost. But then for a running hospital, the staging, look at all the additional costs for contingency, and make sure that, we can stop the main hospital because we're replacing 2 cooling towers in 2 months, or, for example, a sewer stack, we can stop the whole sewage system to replace the whole stack. So it has to be a stage, and then all the project management on the hospital size and so on, they are add up to very high figure. In some of these projects, it was over 60%. So the asset replacement, and it's $1 million, then you add 60-70% depends on the project. So again, this one is a schedule based on the issue across that applicable facility. So you can put all this data in a fancy software, but doesn't really need to. If you have a good knowledge of Excel, and you can write a macro and basically, okay, I've got 10,000 assets. These asset is at this life cycle need to be replaced in 7 years, so I'll put a budget for that year, and with all the other cost component, you just add it up and get the figure. So that's I said, it's an example, it's average across a few buildings, it's just per one building on average. That would give you, okay, that's if we want that particular building had to go up to 2040, we ran the model to 2045, so to give 25 years. And those yellow bars that in tens of millions in the earlier, those are all the issues identified. I say, like, for example, ICT, the project would cost $5 million. If we're not knocking down the building in 2030 and get a new hospital, then we have to spend that money. So yeah, basically that would give us as accurate as possible. I said it's just also a review of all those classification data that you do in the beginning, and the check that you do with the asset register. Then it would give you to consider that covers those assets in the model. You can't go to the manager and say, okay, on average, I've got $138 million to maintain this hospital. That's only for building and facilities. It doesn't cover security. It doesn't cover cleaning. It doesn't cover biomedical assets and so on. So what you put in the model, that's what you get. So basically, yeah, that's basically the process in a simple, quick 10, 12 slides. And that's where we got to. So yeah, the model was bottom up, goes through those 5 cost components and give you the expected what needs to be done to extend the life of this building if we want to do so. That then you can make a good decision that okay. Yeah, all right. If we need to, yeah, do we build it or do we go and